Welcome, ladies and gentlemen, to problem number 7, and we're dealing with continuity and differentiation. And from your sheet that you should have printed from the internet, from my webpage, it says using the definition of continuity and the theorems on A1 and A2 show that the definition of the derivative of f at x equal a can be written as the limit of f of x minus f of a over x minus a. Alright, well, I'm going to give you a little bit more time. Peter, John, Mary, Audrey, and Elizabeth, and Patricia, give you guys a little bit more time to work on that, and let's take a look at that. And it says, show that the definition of derivative can be written as that. So let me pause the video, and we're going to take a close look at the definition of derivative and see how we can go from the definition derivative to this. So I want you to take a few moments to think that over. How could I take the definition derivative and put it into that form? Let me give you some time to think that over, and then we're going to go through that step by step, okay? All right, be right back. Okay, ladies and gentlemen, so here goes the basic definition of the derivative. And we want to be able to show that we can take the definition of the derivative and put it into that form. Well, this is going to be just a simple use of geometry and exploiting the use of the line segment as I did in the initial proofs of using the definition of continuity to show that if a function was differentiable at a point, then we were able to show by using the definition of continuity that it was continuous at the point. So now let's take a look at some geometry. So now just making use of this little line segment, we'll let this be 0, this is a, and this is x. And this distance between here is delta x. So now I know that a plus delta x is actually equal 2x. So from that we already have that, and now doing the additive property of equality, if we add negative a to both sides of the equation and using the additive inverse and additive property of equality, we also find out that delta x is equal to x minus a. So now all we're going to need to do is use substitution. That's all that is going to be required to transform this definition into that. Let's go ahead and do our substitutions. Well, we already know that delta x can be written as x minus a. So let's go ahead and do that substitution. So now I get the limit of x minus a as this approaches 0. And now as we see here that x is equal to a plus delta x. So by substitution I get f of x minus f of a. And again, from our little segment here, our line segment, we also again see that delta x can be replaced by x minus a. So here we have x minus a. Now to finish this off, all I have to do is apply a little bit of algebra. I'm going to do the additive inverse and the additive property of equality across this arrow. When these add, that becomes 0. So now I have the limit, well, this is drying out, the limit as x approaches a of f of x minus f of a all over x minus a. So now we have used all those properties listed on sheet A1 and A2 and our line segment here to transform, to change this definition to its other equivalent form. So it was just a process of using algebra and substitution and a little bit of geometry. Let me know if I moved at a good pace. I just want to make sure that I didn't move too fast, okay? Adrian and Patricia, Julian, Brian, Pete, is everyone here, you guys clear on what I did here? If there's any questions or if there's anything here that I did that you don't follow, I would ask that you ask me now so we can discuss that. And for you viewing this on the website, if there's anything here that I did that eluded you, that didn't come quite clear to you, I'll be glad to discuss this with you. Anything that's on my website that is free, you can contact me either by way of email or call me, and I would gladly discuss the process that I used in order to show the transformation of the definition into its other equivalent form. So please let me know if I did a good job of explaining this work to you. So as of right now, if you did not get a chance, an opportunity to copy what I did here, please do so now. Thank you for joining me, and I look forward to seeing you in other series that I'll be producing and putting on my website. Thank you for joining me. At this moment, please pause your video so that way you can copy the remainder of the work that's on the board if you did not get a chance to do so. Once again, thank you for joining me. Have a very good day.